Welcome to Frankly Developing. I'm your host Frank, and last time we started to do a code review on a poker API, but we found several problems in the evaluation of the different poker hands. And so I thought this is a good situation to demonstrate how to develop a more complex logic like this. We will start with simple card rankings and go all the way to the more involved tiebreakers and develop all of this using TDD. So let's get started. So here we are with our developed card and suit and rank, which we did in this previous video. So take a look if you missed that one. But for now, we want to continue on these, and to evaluate a hand in poker, you need a hand, like not the physical hand, but 5 cards actually, which are called a hand. So let's get started and write a test for this and develop it in TDD style. We have tests for the hand, and when we create a hand, well, we want a new hand, which doesn't exist yet, so now we create it. And of course we want to have some kind of relation to the cards and add cards to the hand, maybe parse them even automatically. So let's get started with a factory method that takes all the 5 cards as a string or string array. And now we have our call. We need to implement it, but only as far as this. We could refactor things like rename this to cards, and that's about it for TDD. Like, the exception is the only problem. If we run the test, it'll fail just because of that exception. So of course we can just fix that by what is it? Hand test. We can fix that by simply not throwing an exception. And of course, returning a new hand. Okay, but now we have nothing to check for yet, so maybe the hand should have some cards. And we'll make sure that one of our cards, like the 3 of spades, is in there. Okay, and so we could parse the complete string already, or we could just or we could just take it for now. Say, let's just create that single card where we have a rank 3 and a suit spade, and make that our hand. And if we run this, it's basically ignoring our input string, but it works for now. So the typical problem we have, we want to deal with multiple of these. Same trick as last time. If you didn't see the video, we're going to introduce theory. And now we have the same test as before, just with inline data. We have the input and the card container. Now I can run a few more versions. And basically add a few more cases until we're satisfied that we have a good enough sampling space that we're looking at here. Maybe I want to have one more for the final one being checked. It does contain this one. And now we have to implement it, because obviously these tests don't work yet. Of course, this is all rather easy so far. So we have 4 simple usages here. But we did not really ensure that our hand has enough cards, 5. So no matter what we do, we need to make sure that we have some bad tests as well for hands that don't work. And we wanted to throw an argument exception when we pass in something bad, like 1 too many, 4 or 3 only, or even if you have multiples in there. And of course, none of that works yet. Oh, and we actually found a problem in our previous use case test, in our previous test here, where we had like invalid hands. So we just fixed those. Now that we increased the amount of semantics that we test for and ensure that we have these 5 cards, we also need to go back to previous tests and fix them, because they use these invalid ones. Okay, so now that's valid, and if we specify invalid cards, we already have that covered through the card class itself that we're using, so we don't want to test for that here, since we know that the card from will definitely take care of that already. And that's really all there is. There's a card, a hand full of cards, nothing more than that. Now we can start actually running evaluations. Okay, so to evaluate a hand, we first need to create one, obviously. So let's pick our straight here. And then we want to evaluate it. And now this is where we come into the designing area. So we can create such a method, and right now it returns void, so not very helpful for evaluating a hand. But what do we want instead? This is the part where we have to design it. And we've seen in the original service, or was here, that a simple integer was used, which is super simple, but again, it's a primitive thing. So maybe we can do better than just an integer and give a bit more information. So if you don't know the poker rules and how the hands are ranked, check out the previous video where I detailed all of the different hands that we can rank. But we also learned there about the tiebreakers and a lot of things that are involved. So maybe it's not a good idea to encode all of that in one integer, and we rather evaluate the hand independently of comparing them against each other. So let's just find out what someone has in terms of the poker ranking on their hand and get back like a evaluation or ranking of this hand, something like that. So we need to define a type ranking. Okay, so for the ranking, we definitely need to rank the different hand rankings that poker allows. So maybe for this one, we call it a hand rank that should be a straight. So we define an enum again. And to make it work, our actual code needs to return that it's a straight all the time. And now, same thing as last time. For the enum, I don't care about having many different tests for all these things. We will develop all these tests for all the different ranks anyways. So for now, let's just fill out the enum. Okay, so here we are with all these, currently only the straight, of course, is being used. And now I can already start to implement a few different rankings and get examples for these different straights, different high cards pairs, and so on combinations. So we will end up having a lot of these tests again that look pretty similar. So why not make it a theory again? Okay, and now we can define more examples for each of those. Okay, now we have one example for each of those already in place. And you notice that I'm doing 2D in a bit different style, because here the problem is super clear in terms of the poker rules being already available to us. We don't need to do a lot of exploration work, and that's why we can quickly define a whole bunch of tests that we know makes perfect sense, and can then go back to the implementation and try to implement the evaluate method so that we can at least get all of these correct. Before we can get started on the implementation, I have found a few mistakes here. So straight flush and royal flush seem unused, but I did define some, only mistake D in them. So these of course should be the straight flush and the royal flush. And while I go fix these, if you appreciate this demonstration of how it looks like in practice, please subscribe to the channel, show your support, and keep things going on. So to save a bit of time on the video, I just finished the implementation. It took me about 15 minutes. So here's the basic idea. We group the cards by their rank, and then we also group them by their suit, and we order them by their rank. And based on these three structures, you can rather easily determine what each of these special cases then is. So for example, a 4 of a kind, you can just see that you look at the by rank, and then you say, okay, the count of one of these ranked groups is 4. So you have 4 things grouped by the ranks. So 4 of the, what do we have here, kings. 4 of the kings get into one group, which has 4 elements, these different 4 cards. And that's how you can easily determine 4 of a kind, or any pairs, 3 of a kind, etc. And something like the straight is similarly using the rank and making sure that all of the groups are actually count 1, so you don't have any duplicates, any pairing in there. And then we use the zip function simply to check that they are in successive order. So you can use the integer casting of an enum there, just make sure that they are successively ordered to find out if it's a straight. Similarly for the royal flush, you do the same thing, plus check for the flush by the suits, and then make sure that the whole card list that when ordered ends in the ace. So super simple rather, but a lot to write, so it's already done. And now we can actually concentrate on defining a few more interesting test cases, because we want to make the more complicated cases too. Actually, you can extend it to the existing ones. So what we have here is, let's pick an example with a 4 of a kind. We have the 4 kings and someone else who has 4 queens. Well, they have a worse card, a worse hand essentially, and we win with the 4 kings, but we lose against someone with 4 aces. So it matters if these 4 of a kind are kings or queens or aces, which means we need to somehow keep track of that too, which we can do by extending our test and say, okay, we want to have like the strength of this rank as well, which will be, in this case, the kings. Let's define the strength of all of these in one go now. And we already noticed the first problem. With the 2 pairs, the strength is not only based on the kings, but we also have 8. So we would still lose against someone who has kings and jacks, for example. So we need more than 1. Okay, so here we are, and have to find all of these rankings. So 2 pairs with king and 8, 3 of a kind with king. The flush is interesting because it means like all of the cards ranked in reverse order. So if someone has a king, queen, 6, 8, and a 10 of some other color, the suit, then they win. So that's why we need to compare all of them potentially. And the royal flush, that can't really have any ranking like this because it's already all the top to the aces. And so everyone has only a different suit, and there's no tiebreakers suit available. Okay, so now we have to actually go implement this. And so we can do the same thing here and say our strength and set it for each of the different cases. And when we're done, we'll return the strength now ranking, and should hopefully get our tests back into succession, or into working successfully. Okay, and we have all the working strength ratings available. So finally, the last thing we need is the kicker card. And the kicker card we can actually potentially add to this strength directly for comparisons. So if you have a 9 high card strength, then if you cannot decide by high card and you cannot decide by the 9, then you look at the kicker, which would be the 8. And similarly, if you have a pair of these kings and you cannot decide it by the pair because the other one is kings too, then you can just say the 9 is the next strength comparison you can use later. Then you can compare 9 and 10 as a kicker card. So let's complete the list like this. Okay, and there we are. Have a whole bunch of tests. You can compare all of these and even already include the kicker cards. So, of course, you could add more of these samples if you don't feel safe about it. The next thing you would do is make this ranking data structure that we built a comparable thing. So you can compare these, which would be very simple. You compare the hand rank and then the strength cards one after each other until you see a difference, or end in a tie, of course. So that would be so straightforward that we don't continue here at this point. So you can see that TDD works really well for this. You could also define these tests super easy and super fast. And if you don't go this all the way back and forth each time for every single thing and build it up, if you're more experienced, you can do stuff like this and get a bunch of them, at the risk, of course, of missing a few crucial test cases for things that you're not feeling comfortable with. So sometimes you can also go back and see, like in the code, there are certain things that you notice that you might want to test more thoroughly, and then add a few more test cases as well. So this is like the risk that we take as more experienced developers. Say, we think we feel confident in this one and do it, or maybe if you mess up, don't do it. However, if you are not confident enough and you kind of dubious, you can just always add more tests to gain the necessary confidence that you're doing the right thing here. So how would you continue from here on? So next thing, as I said, you need to compare the rankings. And again, you can use these theories and run different scenarios of comparing two hands against each other, see who's the winner. And of course, if you wanted to actually use this as a replacement model, you need to hook it up to the API. Just let me know in the comments if you want to see some of those. Thank you very much for watching. Have fun developing.